Hi everyone, good morning. Myself Malay. I work in Manthan. Manthan is basically I'll just go about. So, as as I said, I'm a chief architect, and basically I take care of also data science, though I'm a chief architect, because it's other than that I do also take care R&D activities in Manthan. Mostly as Manthan, actually we are mostly focused in retail and CPG and QSR as a domain. So we are a product-based company. We have multiple product portfolios across all these industry. So we have customers across globe, starting with the US and even in India, for example, Future Group is one of our customer. So they use our analytical platform, and as you know, when you have an analytical platform, as part of those platform also you have other advanced analytics module or use cases which are specific to retail, which we solve using advanced analytics modules, right? And that is a short introduction about Manthan. And these are certain accolades by various industry. So today I'm going to talk about explainable AI. If you understand the whole domain of AI, machine learning is moving so fast that it's very difficult to catch up. One is, and the other thing is basically a lot of these models or deep learning models or machine learning models are being consumed by various industries across domain, right? But it so happens that it is very difficult if you say somebody like a data scientist to explain how this has happened. It's really difficult because he doesn't know, because it's sort of a black box, right? Because nowadays the complexity of algorithms are so huge that you have so many neurons in, for example, if you talk about deep learning, you have a lot of epochs running. So basically a lot of iterations are happening, and by virtue of that you are getting some sort of result. But it would be very difficult for anybody to explain how this has happened, or how did you arrive on certain score if you are trying to classify, for example. Or so explainable AI was already there, but nobody was focusing, because now what has happened is AI is being consumed across different industries and domain. For example, if you talk about healthcare, for example, as my earlier speaker was talking, so basically in healthcare it is very crucial that you know why this decision has been taken. For example, nowadays already in credit score market like FICO and all, people see your score, and on the basis of that, some model would decide whether you are applicable to get a loan or not, right? So all these models are being already consumed in all these industry, where sometimes it so happens that you cannot explain why I being treated like this by organization. Suppose I go for a loan or not. It could be that the model has found out you had some anomaly, and on the basis of that it would have scored you something, right? So it becomes very pivotal for the industry to understand how to explain. So today I'm going to talk about a lot of papers because it's a new topic, though it was old, but now because a lot of research is happening. So I have gone through many research papers in the industry. I have given references of those also. And basically I'm going to demystify, or so to say unclutter, those understanding for you about explainable AI. In fact, at Manthan we are trying to see how we can consume some of these, so that when we go, because we have big retailers and they have a big data science team, in-house data science team, right? But when you go to a functional user, he doesn't understand why it is being like this, right? So somewhere, can you have a process whereby you can justify why this why this has been like this for whatever model. Suppose we have products like customer analytics, where we try to basically, as part of a churn model, we try to say how many percentage of customer who churn out. In fact, we say the time also, the recency and other factors also, frequency, how many times he should come. There are a lot of factors actually, and it is very difficult when you go to a business user. He doesn't understand on what basis, because he is seeing something. For example, simplest example could be recently what we were facing, almost all maybe 6-7 months back, when we have a recommendation engine, and basically these recommendations are consumed by our personalization engine, which basically consumes this recommendation and try to push coupons. In fact, Future Group uses this. So basically, whatever the payback alerts that you get in mobile are through our platform. So it so happens that if you try to push something, right, and you want to know actually whether these many customers should be given this sort of coupon and with this sort of discount, how do you know? And basically, how do you tell the business that this is what we should give 10% discount, for example? Of course, business can take a call whether to go ahead or not, but there should be some sort of explainability about all this, right? Excuse me, can I have some water? Where is she? So because of all this, explainability is very pivotal going forward, and that's where a lot of research is happening within this area. And I will also talk about few frameworks. In fact, I don't know how many of you attended yesterday's session, where Bala from AWS was saying that as part of SageMaker Debugger, they have introduced Shape. Shape is a algo which is being integrated by AWS recently. And because the whole industry, because the consumption is like that, the whole industry would slowly try to tend to sort of consume these sort of things, basically. And so essentially, these are my topics because I have so much content. I hope I should able to finish it within time. So this is just some quote which I found very interesting in certain paper, and I have given the reference also. You can check it out later. And why basically explainability is very important. And I sort of said in my layman-ish way before, but this is more of to the point why it is required actually. I'll move on. So this is from DARPA. I don't know how much you know about DARPA. DARPA is equivalent to DRDO, and this is very famous in industry because this is like an AI wave, right? And thank you. This is like an AI wave, and basically, if you see, there are 3 waves. In fact, it so happened that nowadays people have come up with the 4th wave, which I'll talk. I didn't want to mention because that is more of an extension to this, and this is more of like the 3 pillars, so to say, where the first pillar is within the time frame of maybe 60s, 70s to 90s, where basically everything is everything happens through rule or through heuristic approach, right? Now, it so happens, a lot of models are not generalized. But then comes the next statistical learning approach, where basically still it goes, this cycle as per the DARPA paper goes till 2019, where basically it is to certain extent generalized. You can prescribe certain things, but it's still not perfect, right? The contextual adaptation, which is the 3rd wave, which is basically from 2020 onwards till 2030, would take care of many things, like because already certain things are happening, like image recognition, conversation, all these things would mature. And as part of the fourth wave, what people are saying, or as part of some industry folks have extended this, where people are saying you would go to a stage that is basically after 2030. So you would achieve sort of, so to say, nirvana, where artificial general intelligence and possibly may be leading to ASI, which is basically artificial super intelligence, right? Where, I mean, it will be like sci-fi movie. A robot can do many things for you, which is a dream. I hope at some time we will reach that. Then we don't have to do anything. So this is the, so basically what is, as I said, when you talk about explainable AI, it is more about depicting or deciphering the black box that happens across certain algos, like for example deep learning for that matter, right? And there are a lot of business risks, as you know, if you are using this, then it calls for a lot of business risks, and basically to overcome those you need explainability, and these are very vital for industry like healthcare, crime, for example. I have given references where there was some system which is being used by US court, and there is a consortium, judge consortium, which was using a model, and that model was basically biased towards certain community. And that can happen in machine learning, as you know, because whatever data that you are having, that would be biased. So for example, if I want to do something, I collect certain data, and that data could be talking something. The simplest, funniest example could be like, I don't know when you have seen or came across this or not. Few years back, when you ask Google who's Papu, it will say somebody, right? I don't want to name, but because it infers, so basically, suppose all the data is talking about something, machine learning doesn't understand what is true or what is not true, right? If everyone is trying to talk about certain matters, so basically it try to learn those, and basically, so essentially what happens, it learns those, and when you ask, it basically tries to give responses related to that. It doesn't understand. So that is where human has to come, and there is a human in loop concept also. A lot of people talk, there are papers where basically you as a human has to tell this is not correct. So you have to override, which is to a certain extent in a simpler model you say feedback loop, right? Where you have to give a feedback loop so that machine understands what is right, what is not. And there are, as I was saying, the risk could be across industry. The other thing is autonomous industry. Very recent news, I don't know how much you have seen in the recent, maybe a week or something. There was a news about Tesla vehicle auto steering off into different path. In fact, in China, some couple have taken photo. It seems it has steered off to a lake. And of course, Tesla says it's no. But when you have all these things where there are certain actions which model takes, and that can call for lot of risk to human or any other thing, the severity is more, so to say, then explainability becomes very, very crucial, because at some point I'm very sure within this coming 5 years or within a decade, this will become a standard. In fact, I don't know how many of you have seen, I was trying to, even Facebook, for example, when you say like and all, there is something they have recently done, and it shows you why it has taken this call and why it is showing the ad as part of the mobile app. You can check that in the Google actually. So basically, black box AI leads to all these issues. To a certain extent, I have told, but let me see if I have. So as I said, erroneous decisions, overlook vulnerability, and so basically, if you are doing audit, there are a lot of audit system nowadays, right? And it can take a call which is beyond your perception, why it has done, right? And depicting those is very, very difficult, right? Because there are a lot of automation happening and lot of iteration happening as part of the model, maybe, right? So this is sort of an architecture. This again I have taken from DARPA, and of course I have beautified it. So today this is what happening, where you have training data, the machine learning process runs, whichever machine learning process. I'll come to those tech part later. And then you learn, they learn from the functions, and basically there is somebody who consumes. The user could be anybody, right? And but there are questions which cannot be answered because you don't know why this call has been taken, why not something else, and all these sort of questions. But with XAI, which is a short form acronym for Explainable AI, the industry is trying to basically answer those. Of course, everything is not perfect because it's a very new domain, and I've been seeing since last 3 to 4 years there are a lot of papers. Before that, the papers were very less because things are getting consumed in different industry, and you have to make sure that explainability comes as a vital thing. And a lot of bigger organizations, I'll talk later, who are pushing through this, and they are publishing papers, frameworks, and all those. So with the new model, what would happen is basically you have similar training data, you have new machine learning process, which I'll talk, then you have an explainable model, and then there are explainable interface. Because consuming explainability, if you ask me, I will say some formula, for example, function of x, a linear regression, for example, intercept plus coefficient of some variable. Nobody would understand that. So basically you have to think how this can be consumed across different industries, right? If you are talking about retail, for example, retail how people would understand this. If you are talking about pharma, how pharma folks would understand. So the domain centricity and comes into play, so whereby you have to take that into account, and basically you have to explain through certain interfaces which is easy to consume from the business user point of view. And in this, if you see, there is the subtle difference here is there is a feedback loop also. If certain things are not working, then whoever is the consumer or recipient has to basically give back again those feedbacks, so the model gets perfect, right? And the anticipation as per DARPA is something like all those questions which were earlier unanswered to certain extent would be answered. But that's the vision, and that's what everyone is leading to. There are a lot of definitions across any paper, or for that matter Wikipedia, so to say, about what is explainable AI. So I liked few and which I have jotted down here, and there is one so to say, not confusion but conflict. I will talk also about that. People understand explainability as many other things, because we as human try to use lot of words and interchangeably, but they are not so. Like for example, when you say explainable and when you say interpretable, it could be different for different fellows, right? For example, I might think they are both same. But for example, when you ask somebody who's producing or writing this code or algo and producing this explainability, he might explain in certain way, but you may not interpret those, right? And so basically there are subtle differences, but mostly people try to interchangeably use, because this is maturing. At some point there would be a demarcation saying that this is what it is, this is what it is. And for those, there are many consortium being formed by bigger organizations like Google and Facebook type. So I hope at some point they will all agree, yeah, this is the demarcation. When you say explainability, within this you should say anything, because as I said, even I explain something, if you cannot interpret, it's not explainable for you, right? Because you didn't understand what I said. So somewhere I have to explain in such a way that you, as whoever, from whichever domain, should understand in your nuances whatever you understand, right? So there are differences also there, because a lot of these advanced models are more following towards explainability, but the older models are more towards interpretability, and they have sort of a clash. I will talk about those also. And there are a lot of hype, anything in this industry, especially towards AI, a lot of hype. And there is, of course, hype also about explainability, right? And while the black boxness nature of any sort of advanced machine learning algo is known, but nobody has bothered how do they go about solving it. Now only people are coming up and trying to say, okay, this is how it's supposed to be. And unfortunately, as you know, being in AI industry, everything is a little hyped up. So anything that this thing was that anything that you take, you should make sure that, because a lot of these explainable model, in fact in Manthan we are trying to see how we will consume few of these algos as part of our use cases, what we consume. So you have to take with certain pinch of salt, because everything is not perfect and they are not, so to say, productionized. There are certain modules from companies like Google, and I have mentioned other companies also, which are working towards it, and you might consume them basically. And I hope through that a lot of this will be productionized. But this is right now, I would say it is helping, but it is not to an extent that everything will be solved. But the whole idea is to lead towards that. So how do you realize the explainable AI, given that there are a lot of confusion, a lot of papers? There is, as I said, no single entity who tries to say this is what it is. But there are papers who try to do that. There are certain universities. I have taken this from one paper which is very interesting, I found, and I've given the reference also, and you can see that. And they try to basically go through all the papers, all the research across industry, and they have tried to categorize within certain dimensions, and those dimensions are these: functional, operational, usability, safety, and validation, right? And all of these dimension has nuances. They have very nicely portrayed what it is and how you should go about certain things. I will go through those. So, for example, functional. When we start with the functional dimension, it's mostly meant for engineers who are tasked to identify what algo to be applied, right? And when you do that, you have to basically make sure that a lot of these things, which I am saying as a properties, has to be taken into consideration. So, for example, the first one I have, because there are many rules as such, so I have quoted it as F1. So, supervision level, right? Because see, explainability approach can cut across different level of machine learning approaches. For example, an explainability can be applicable to unsupervised, semi-supervised, supervised, or for example, reinforcement, right? Now, how do you make sure that you have to make, as a developer, take into account what you are doing and how do you explain? That is what this property says. Then the problem type is something where basically you can identify multiple type of algos where you have to make sure that you are justifying to yourself. So basically, if you talk about classification, you have again within that binary, multi-class, multi-label, probabilistic, non-probabilistic. So when you are, so you have to make sure. So this is just guiding principle somebody has to adhere to. Then the explanation target, right? It's a with general functionality and conveying conceptual behavior. So it is very sort of very difficult when you are trying to explain for certain target. So now, for example, I'll try to give some example where you are having data, both raw data and features, right? and you are trying to predict. Explaining the first one may be very difficult, even so to say impossible, because of the model assumptions, right? So when you are targeting, you have to understand also what sort of assumption you take, and you have to account those assumptions also as part of your functional properties. Then this is basically the breadth and width, because it can be you can have models or explainability across multiple so to say stages, right? One is local, the other is cohort and global. Then comes the computational complexity, because see, when you are running models, complex models, so it might take somewhere you have to, as a developer or a data scientist, make sure that you have to also explain the complexity that is involved, because it can happen, certain model can take certain resources or certain time. Now somewhere you should depict that if you do this, it might take some additional time or some sort of this thing. I will run through this because I have a lot of slides, so I will go to, so these all, I think anyway the slides would be shared, so I will go through some of the, this is again compatible feature type, caveats and assumption. If you are taking some assumption, you should make sure that those assumptions you are also explaining as part of your narration or something, right? Now comes to the operational dimension, which is basically considered from a deployment point of view, because that was more from a data science point of view, a data scientist or the algorithmic developer point of view who is implementing. Now comes the operation point of view, where you are trying to deploy it across various segments. So if you talk about explanation family, there are 3 types. So one is basically association between antecedent and consequent. I don't know how it is not showing there. And then constant and differences and causal mechanism. Similarly, you have medium through which you are doing, you have to take care of certain things. Then system integration. I will run through because I have a lot of slides. So which all are important I will tell, because a lot of this, I don't know, maybe not that interesting, but they're part of this paper. And this is domain, then data and model transparency. The audience. This is very important because, as I was saying, if you know the audience is a business guy, as I was saying, and if he is understanding certain business domain and he understands certain business lingo, then the explainability has to be like the way he can perceive, right? Rather than you writing something whatever is common. So the explainability cannot be common across all. You can have a common thing, but then the problem is that he may not be able to interpret everything, right? Then there is causality and actionability. Similarly, trust and performance. This is also a very important topic, because somewhere you have to, and this is something very interesting, because as you understand, a lot of these models, as I was saying, the simplest model that you take, they are more explainable. Whereas if you take the complex model, if you see this graph, the accuracy is in the y-axis and the explainability in the x-axis. So if you see, the accuracy is always very good when you go for a classification rule. But when you go for but explainability is very bad because it's in the right hand side. But if you take something like neural net, the accuracy is very good, but you can't simply explain it because there's so many things happening there. Similarly, there is something called provenance. So explainability should be transfluent, and so most often provenance of explanation can be attributed to reliance on a predictive model. So basically, if you are using a black box model, then whether it is reliable or not. for example, purely model-driven explanation, interpretability point of view, if you are using, for example, k-means. Now, when you use k-means, number of groups are very difficult. There are multiple techniques where there is nothing best as such. You do this curve technique and other thing, but if you have a huge data, then you don't know what is the right k. People might take 10, 5, the grouping clusters, right? So somewhere, all those things are very important also. But so basically, if I want to classify this whole audience by gender or something, gender is easy, but other attributes if I take, then if I put 5 groups or 2 groups or 3 groups, then even it would not be right? So when you talk about that, then you have to think also on what basis you are thought about those k value. This is sounding, I will just go ahead faster because there are interesting, this chronology, coherence, you can go through all this in the paper anyway, I have given references. This is from the usability, which all are interesting, I will just stop by. Safety is very important because as my previous speaker also was saying, like whatever you do, how safe it is. If suppose you are explaining, you should not also disclose certain things. They are very difficult, right? If I am trying to explain certain model, and as part of that model, I have to basically make sure that I have to explain something, then how do I make sure that I am not leaking out some info, which is very crucial from whatever domain I am working with, right? And there are misuse attributes where it says, how do you handle those? Then comes the validation. So the validation point of view, there is no simple way to validate. One is basically you go back to, you do some user studies, you do survey, find out whether it's working, right? You talk to those business user, whatever explainability you are doing, is it acceptable or something not. Then there are proxy way also, and that is synthetic experiment. So you don't say because people don't want to participate, they want anonymous, they can participate. Okay. So when this would be interesting. So when we talk about models, there are a lot of models about explainable AI, which is model agnostic, and those models are these. It's called also post hoc explainability. Why? Because what happens, most of the models that we are doing right now is you have certain data, you understand what, you take that data and then you run some model on that data, then you come out with your, whatever you are trying to run, the understanding. So basically what is happening is you have certain data, on top of that you run, the event is happening after, because once you have the data, then you learn something out of the data and then you infer and take some calls. And that is called post hoc. And there are multiple approaches. I would talk mostly 2 which are very vital. All others are very simple approaches like partial dependence plot. So basically it's like a plot which shows marginal effect of feature to the predicted outcome of any model for that matter. Similarly you have ICE, which is basically individual conditional expectation. But I would talk mostly about the advanced ones, which is LIME and SAFE. All others are sort of graphs and other things, right? So LIME, the full form stands as Local Interpretable Model Agnostic Explanation, and this is one open source, which is now basically being consumed by most of the other industry folks, which I will mention after some time. And this is for any sort of classification, you can use this. Just to explain something, this is some way it would try to explain. But if you see, this is also not very sort of user friendly. So what we are trying to do, this is the URL I have given as a reference, and you can check. This is open notebooks from LIME project. So this is just a simple regression model where I'm trying to, it is using some sort of, I think it is using some random forest or some sort this thing where it is trying to forecast on some open data actually. But if you see, so the red is positive, or red or whatever, orange, the negative is blue. Now if this is what the output it will be, if it is still not, so to say, very friendly. So what we do is basically, if you want to consume those somewhere, you have to start using natural language generation sort of framework, where you take this, either you have a template or a model, and you try to express those in a natural way. And that natural, so the model could be specific to your domain. So suppose you are talking about, as my previous speaker was talking, if you are talking about healthcare, then there will be a model which is specific to healthcare. If you are talking about retail and certain type of retail, then you talk about, you have a model which it will be used, and basically try to interpret this in a language which is more consumable by the retailer or whichever industry. This is basically another model, safely additive explanation, and this also does to a certain extent the similar thing, but it gives you a different type of plot where all these variables you get to know actually whether they are significant variables actually. The lower is on the right side and the higher ones in the left side. This is another one where you try to create dependence plot to show effect of a single variable across the whole data set. So I think RM is average number of rooms or something, some data. This is open data again for the notebook what I have given. And it's basically the pricing of some Chicago or some sort of those data sets. This is all I have taken from the line, this thing itself. And this is summarization actually across all the variables which are very vital and feature-wise. And now this, if you see, I can always show this. People show all this in their dashboard. But is it consumable? For that you might take some technology like energy. Like there are many, if you have Tableau or something, if you are using, people use narrative science, for example. Narrative science is an energy tool. And so you can have models, though they are not very advanced, but right now they promise also they have advanced models where you can pass all this to their template, and they have a corpus which you can give, it gets trained, and on the basis of that, next to the graph, you will have explanations which are very sort of comprehensible to whoever is consuming this. Then comes the model-specific explainability, and so these all are basic ones, right? These all are not those advanced ones, and so these are the statistical based or those things. Here actually, and if you, I'll talk later, but it is mostly when there is a this conflict, as I was saying, these all are comparatively easier to explain, right? Whereas the deep learning and other models are not that easy. And these all are various companies and frameworks what I found are interesting, and some of them we are doing POC also. So Google has something called What If tool. I don't know how many of you have used recently, not very recent, but I think I've been seeing them since almost a year or so. Then there is something called Deep Lift. This is also another framework. Skater is, I think, backed by Oracle. This is another framework which is used. Most of these guys, either they have come up their own models, which is not exposed like Google and all, but they have their own visualization. They use TensorBoard and all, and they try to showcase those. And this is another one, LE5. It's a Python package. This is an open source one. AIX 360 is backed by IBM. And this is also being consumed, at least I have seen a lot of use cases. Data Robot has something which I recently saw was more interesting. Then the last one also, it's a open source, I don't know open source or, but it's a freeware type I saw. which is very interesting. You can check out this explainer.ai, and it has very intuitive visualization. And of course, I think they are also using TensorBoard or something. They have examples also where you can access those and check it out. Mostly use Chrome, or else it doesn't work, I've seen generally. And this is more of a evaluation of explainable AI, and this is again by DARPA, how you should evaluate. Generally, without going this, the idea is when you evaluate, you have to use those business users. You have to use those business users, whatever explainability you have to cross-validate against many of those folks, because as I said, there is no perfect explanation. There are a lot of things human as such can reflect, because if you understand certain things certain way and you are biased toward that, you would, whatever I explain, you would always think that, oh, this is the way it is, right? So, but you try to justify, because you are in a business where you have to explain, so you have to explain in a manner which is domain specific, and that's all is very vital from an industry point of view. This is one workflow where, this again from DARPA, which is interesting. So this is the process and what sort of measure you take. So as a user, you receive your explanation through whatever technique, as I said, and if it is fit from a goodness criteria point of view, then you are done with it. If you are not happy, then you test again. If you want to revise it, then you use the user's mental model. Is basically that where you create a model and you try to see actually whether it is adhering to that specific to whatever domain, right? And if it is not right, then it comes back to inappropriate trust or mistrust. Then again it goes back to this thing where it has to go back as a circle. Or else if it is enabled, then you basically try to make it good, so you have to basically test it, and then if it is fine, then you gracefully say that, okay, this is acceptable, I can move ahead. These are a lot of myths also. There are a lot of myths, and this is, I have given a reference. This is not publicly available. This is a Gartner report which I read. I don't know whether you can download it or not, but it talks about a lot of those myths. One is basically lack of explainability is a new problem specific to this black box AI. It is not, because this is something there, as we know, right? And all black box AI must be explainable and interpretable. This is also not true. At least, because as I said, there are biases everyone has. Whatever way I try to tell you, you might say that it is not correct, right? There are resolution also. And this is basically the myth that explainable AI should be able to explain everything as part of whatever black box AI, and whatever decision can be fully explained. But this is not true. If you use deep neural network, as you know, suppose, for example, we have some NLP models which runs for 3 to 4 weeks to come up with embeddings. I don't know how to explain, and then you have to say, actually, do we need to basically categorize what you need to explain? Maybe those are not important. Or you are trying to find out using a hierarchical recurrent neural network for example, personalization of certain things. Now they might also take depending on the data set. And it tries all sort of matrix permutation combination. A lot of things are black box. You cannot explain. So it is not entirely true that every black box AI could be explainable. But there is a try, and at some point you may not think also why you need to do it, right? Because if you see autonomous car, as long as you know this is what, simple thing, for example, Google, nowadays Google gives you prediction for how long it will take, right? At one point it was very bad. It will tell too much a time, or it will tell so less time. because there are certain factors also, because every time you move the traffic is building up. But other than that also it was not that great, but slowly it is becoming perfect. So the anticipation is at some point even deep neural net also should be explainable, and for this actually there has to be some aggregation of understanding and demarcating that we don't want to understand. Now do you understand, even if you're using a race car, how the engine works? You don't give a damn, right? All you want is basically, if suppose there is certain decision which is being taken by this model or something, whether it is within your acceptable criterion or not. And that is very important, right? And there is this myth is always there, because people think always human can take always best decision. But that's not always true also, right? Because you may not know. See, a model came up with certain score. It would have seen so many cases, if and else, so to say in simple English. But as a human, we don't know, right? So always human is right is not correct also. This is again a myth. And this is a fancy one, Explainable AI can be bought, which is from a .NET point of view. And this is what I was talking about, refutation or basically opposition. And there are a lot of opposition also about explainable AI when you talk about papers. In fact, there are papers saying, there's some paper called Stop Explaining Black Box ML Models. I've given some reference also. And if you understand also, even for example, Jeffrey Hinton, you all know that he's one of the founder of AI. He was at some point also was against it, because I have given a reference where you can read what he's trying to say. His hypothesis is because he thinks like a data scientist, right? How come I can explain everything, right? But there are other people who prove him wrong. And this is the one, what I was saying, this is some popular algorithm called Compass. This is correlational offender management profiling alternative actions. This is being used by US court, and they found out that this is as good as just asking some random people and coming with some solution. So rather than trying to create models and then explain them, the folks who support, and mostly if you go through a lot of these articles, you will understand there is a divide between machine learning folks and start folks. The interpretable guys are saying I can always use something like CART, classification or regression tree, right? And I should be able to explain. But everything cannot be explained using CART, as you know. There are advanced version of it, but still I would not agree. So I'm not saying any one party is right. There are truth in both the sides. It's just that we have to come up with sort of some agreement, and as time passes by, the industry will pick up. There are a lot of models which will come. There would be consortium which would say this is how it is. Then things would settle down. And this is sort of the future of explainable AI, sort of what I found across multiple things. So there could be more tools like what if. If you see what if, it's very interesting. One could even imagine system that could evaluate every prediction. I hope given the machines and other things are becoming so powerful and cheaper, I'm sure at some point we will have a lot of these models. And machine learning will be automatic, so will be interpretable. I hope that happens. These are some interesting references. Some you can check. I don't know whether it is visible. There are some book links which are open book, and from O'Reilly, and there is one more guy. I don't have internet, but you can check those. They have nicely explained about all these nuances what I told. But because this is more of a research domain, so lot of things won't get you clarity. because you will get literally confused, because as I said, there is a divide between the interpretable and explainable guy, and so they try to bias using those papers saying that this is how it's supposed to be, this is how it's supposed to be. So the safest bet I would say is basically follow the industry standard. Like for example, you have Google, for example, and there are other companies also which are doing things. Let me go to that slide. I didn't want to mention them because what they do, as I was saying, Bala also about AWS, they take these open sources and they make it like SDK. But these all are in their own separate sort of this thing. But if you talk about Azure for that matter or AWS, they have taken this Lime and Shape. Lime they have not yet taken, but Shape they have taken, as Bala was saying, because that's the beta or something. I haven't seen. I have heard as part of reInvent that they're launching that as part of SageMaker debugging, but I haven't seen that tool yet. What they have done is they have taken this and integrated as part of the SageMaker debugger pipeline. So basically, when you debug, it comes up with all those this thing. Other than that, you have H2O. H2O is doing a lot of things. You can get a lot of paper on H2O. Even H2O do have a lot of things which they try to do, but most of them are on open standard and all these frameworks that I have said. They have not come up with something very different. And a lot of the things in H2O are more these models which they have integrated as part of their pipeline, and they're coming up with nice visualization. In fact, same with the data robot. You can check those. I didn't want to put those because a lot of slides. But you can check data report has a lot of nice use cases where they're trying to do this. I have in fact seen some demos and all. You can check that out. Yeah, other than that, if you have any questions or else I'm pretty much done. I'm also almost done. Whether you can see this, there is some good paper I wanted to highlight.
I have it.
Yeah.
Among Lime and Shape, which one should be used in production?
Okay, sorry.
So
to be very frank, none of them are productionized. So you can try it out. You see, I think Lime is that way easy to comprehend. But then again, see, all these things spit out a lot of these stats and other things, right? But it is not, I would say that if you want to convey to somebody, it's still not comprehensible. Unless you are a data scientist or somebody who knows a little bit of stats and other things. So you have to think actually how do you, as I was saying, use this as part of your input pipeline to something like an NLP process where you try to narrate. Then it will be easier, or else it will be little better than what you had. You didn't have anything, maybe now it is coming up with all this. But is it that where every domain person can perceive those? I doubt.
Okay. Actually, I'm from a healthcare organization where we are evaluating both Lime and Shape.
Okay.
So, in one of our models, we have used Lime, and the output of the Lime is we have positive correlation as well as negative correlation. For every positive correlation, there is something called as weightage that is being associated with. So, what is that weightage, and how exactly is that number coming?
I also don't know how to see. But you can check. It's all open source. You can check.
I'm not able to call that as percentage because on adding up all the weightages, it's not adding up to 100. So it's some number, like it says 0.15 or 0.1.
So maybe you can talk and take my email ID. If I understand, then I can give you some reply.
Sure, thanks.